To begin this particular polynomial long division, we need to make sure that when we're writing out f of x, we include the term 0x to the 1. Even though it isn't written explicitly in the function, we need to include it for the long division to keep the pattern and make everything work. Now, even though we have an x squared plus 2 and not just an x, we're going to follow the same rules as we normally do. We need to multiply x squared by 2x squared to get 2x to the 4th. And then we're going to multiply 2x squared by that entire d to the x polynomial. The only thing we're going to do differently is we're going to write the result when we multiply by 2 a little to the right. So once we complete our subtraction, we're going to have 0 plus x cubed, and then we're subtracting from a negative, so we're going to have negative 9x squared. And we can drop down that next term. Now we look at the x cubed, we need to multiply x squared by x in order to get x cubed. And so we do that and then multiply x by that entire polynomial d to the x, and we'll get x cubed plus 2x. Again, we write it so that everything stays in line. When we do our subtraction, we'll end up with 0 minus 9x squared minus 2x. And we can again drop down that next term, the 7. Here we look again, see what we need to multiply x squared by, and to get negative 9x squared, we need to multiply by negative 9. So we multiply the entire polynomial, and we'll have negative 9x squared minus 18. And when we complete that subtraction, we'll end up with 0 minus 2x plus 25. And from here, we can't do any more division, so we can rewrite our quotient in polynomial form, which is x squared plus 2 times 2x squared plus x minus 9, and then all of that added to negative 2x plus 25. And that will be our final answer.